Right guys, so today we're going to be looking at data representation in a computer systems. Now we're going to be looking at binary numbers and we're going to be looking at what the word denary means. So what the kind of point of this video is, it's going to help you convert binary numbers, which look like this here, okay, and we're going to convert them into denary numbers, which is a number system that's more common to ourselves. It's the same number system we've been using since we could ever learn to count, okay. The only difference is it's got a really fancy name called denary, okay, and that's it there. So if you can't figure out what I'm trying to say, it's denary, could also be pronounced denary. It's up to yourself really, okay. So we're going to be looking at converting from binary to denary, and then we're going to be looking at the opposite, so converting denary into binary, and then we're going to be looking at the different units of storage in a computer system so that you're able to kind of have a stronger understanding of how data is stored and how each storage unit is represented. Okay, now we're going to be looking at that. I've got a Jamboard set up, so we're going to try and work our way through it. The only thing I will say is I am trying to write on it using a mouse. I did order a pen and I tried to set up some fancy system using a tablet and set it up, but sadly the pen hasn't arrived yet, so you're going to have to make do with this writing, and then hopefully throughout the series of videos all of a sudden my writing will improve drastically. Okay. Right, so like I said, we're going to be looking at binary, and if you didn't know what that was, there it is in front of you now in big writing, okay? Now, you will have heard the phrase binary before, maybe not in a computing context, but basically what binary stands for is it's a number system made out of two numbers. That is where the bi in binary comes from, okay? So, I'm sure there's some Latin meaning for nary that I'm not aware of, but we're going to be looking at binary, okay? Now, binary has that name because it is made up of two separate numbers, okay? Now, those numbers are 0 and 1, okay? So like I said, it's not the best writing ever, but it will have to do for the moment, okay? So, binary made up of two numbers, 0 and 1, okay? Now, when it comes to converting a binary number, you have to know and understand how we get our headings or how the headings are worked out. Okay, now to do that, we're going to look at denary. Okay, so I'm going to write denary here so you know exactly what I'm talking about. Okay, so denary is the fancy name for the number system that we use on a daily basis. Okay, so again, we've got DE, then nary, and now what the DE or den stands for is base 10. Okay, now base 10 means that our numbers is our number system. Okay, it uses a base 10 system, which means that every number is represented by a series of 0 to 9. Okay, now if you think about it, if you try to count to 10, okay, if you count to 9, starting at 0 and then you use your fingers, then you're using 10 separate numbers to count to 9, okay? So, and every number can be made up of that. So what I'm going to do is, I'm going to give you a number, so let's go for 321, okay? Now, we know that is 321 because obviously we're in 4th year now or 3rd year now and we're able to count, okay? Now, this number is made up of a series of 0 to 9s, okay? Now, what I mean by that is, it's base 10 numbers, so each of these number is made up by a 10. Now, to get these numbers, we have to multiply these numbers by a series. So let's start off with 10 to the power of 0, okay? Now, 10 to the power of 0 gives you 1, okay? Any number to the power of 0 gives you a 1, okay? Next, we're going to do 10 to the power of 1, okay? So what 10 to the power of 1 means is you're just multiplying 10 by itself this many times, okay? Now, because it's 1, we've already got 1 here, that's just going to be our tens, okay? So 10, right? Now, 10 squared would be 10 times 10, which gives us 100, okay? And then we've got 10 to the power of 3, which gives us 1,000, okay? 1, 2, and 3, okay? Now, this could look familiar depending on how well you paid attention in primary school maths, okay? But this is our units, this is our tens, this is our 100s, and this is our thousands, okay? Now what that means is any number from left to right is made up using these, okay? So if we look at the number 321, okay, that is 1 unit, and it is 2 tens, and it is 3 100s, okay? So our number is made up from these units, okay? It's 1 unit, 2 tens, and 3 hundreds, because it's 321, okay? Now, we do that without even thinking, okay? We've been learning that for such a young age that that is just programmed into us, okay? But that is where it comes from. And binary is exactly the same, okay? So if we go to the next slide here, you'll see that I have already written out these numbers here, okay? Now, these are the headings that you have to learn for National 5 Computing Science, okay? You have to know how to write out the headings for an 8-bit number, okay? Now, what that means is there's going to be 8 individual numbers. Now, these headings, because it is binary, okay? Because it is binary, these are base 2, okay? Because it's only made up of 2 separate numbers, 0 and 1. So if we do the same as I did for the last example for denary, 1 is 2 to the power of 0, okay? Because remember, any number to the power of 0 is 1, okay? 2 comes from 2 to the power of 1, okay? 4 comes from 2 to the power of 2, or 2 squared. 2 times 2 is 4. 8 comes from 2 cubed, okay? 16, 2 to the power of 4, because 2 times 2 times 2 times 2 gives you 16. Okay, 32 is 2 to the power of 5. 65 is 2 to the power of 6. Okay, and 128 is 2 to the power of 7. Okay, now I know I said that it would be 8 separate numbers, but if you again count out in your fingers 0 to 7, you'll see that you have used 8 fingers. Okay, now when it comes to writing this out in an exam situation or in a test or for your homework or your work at home, then all you have to write out or remember is it starts off from number 1 and it works its way by doubling each time. Okay, so 2 ones is 2, 2 twos is 4, 2 fours is 8, 2 eights is 16, 2 16s is 32, 2 32 is 64, and 2 times 64 is 128. Okay, so I always remember 1 and it doubles. Okay, now to convert binary numbers to denary numbers, okay, we have to write out a binary number. Okay, now I'm going to do the first example with you and then we'll move on to the reverse. Okay. Right, so below our headings I have written out the binary number for task exercise 1A, okay? Now, what this means is that any number with a 1 underneath it is basically switched on, okay? So this 1 is underneath 1, okay? So the 1 has been activated. The 1 is underneath 2, so the 2 has been activated. 1 is underneath the 4, so the 4 has been activated, okay? But there is a 0 under 32, and a 0 under 64. So for our binary to denary conversion, we can just ignore the numbers 64 and the number 32 because we're not going to use them because there's a 0 underneath them. Okay, so to convert a binary number to a denary number, okay, all you have to do is add together all the numbers that have a 1 underneath them. Okay, so you're doing 128 plus 16 plus 8 plus, oh, I don't know what I was doing there, so let's rub that out. So there we go. So plus 4 plus 2 and plus 1. Okay, now once you've done that and you've added them all together, that is your denary number. Okay, so once you've added them up, I'm not going to do it for you because that would give you the answer. Okay, then what you do is write down the denary number. So when you're doing the question in the worksheet, okay, then what you're doing is just writing out the number. Okay, now you are allowed a calculator, so if you do feel that you are struggling a bit with the maths, then by all means use a calculator. Okay, and make sure you get the answer correct. Right, now to do the opposite. Okay, right, so now we're going to look at how we convert a denary number to a binary number. Okay, now a denary number just means something like this here. So what we're going to look at is the number 145. Okay, so that is a number that we all know as denary. Okay, now we need to convert that to a binary number using the binary headings we talked about just before. Okay, now the way in which I do this is I start from the left and I work my way along to the right. Okay, now the question I have to ask myself is this number smaller than the denary number that I'm trying to convert? Okay, and if that number is smaller, okay, so if the heading is smaller than 145, I write a 1 underneath it. Okay, so right now what we're looking at is we're looking at 145 and we're going, is 128 smaller than 145? Okay, and it is, and because it is, we put a 1 underneath it. Okay, now what you do once you've done that is you then take away 128 from 145, and that leaves us with 17. Okay, so now the number we're going to look at is 64 smaller than 17? And 64 is sadly bigger than 17, so we're not going to use it, so we put a 0 underneath it. Okay, then look at 32. Is 32 smaller than 17? No, it isn't. So again, we're not going to use it, so we put a 0 underneath it. Okay, and then we look at 16. Now, is 16 smaller than 17? It is. So 16 gets a 1. Okay, so then we take away 16. Now I know you can do that one in your head, but just believe in the process. So 17 take away 16 is 1. Okay, so we now know that we're not going to use 8 because 8 is definitely bigger than 1, so it's a 0. 4 is also bigger, that's a 0. 2 is also bigger, 0. And 1 is the exact one we're looking for, so you put a 1 underneath 1, and there we have our binary number. Okay, so there it is there. So 145 in binary is 100100001. Okay, and that is 145. Okay, so when you type 145 into your computer, this is what the computer actually stores. Okay, assuming it's an 8-bit machine. Now, the last thing we're going to look at is the units of storage. Okay, right, so if you look at the units of storage, okay, they are in order of smallest to the largest. Okay, so the smallest unit of storage is a bit. Okay, now a bit is an individual 1 or 0 in binary. Okay, so it's just one singular bit of information, and it is the smallest unit of storage in a computer system. Okay, it can only be a 1 or it can be a 0. Okay, and that is a bit. Next unit of storage is a byte. Now a byte is made up of 8 individual bits. Okay, so if you have 8 bits, you have a byte. Okay, now next one we're going to look at is a kilobyte. Okay, now a kilobyte is made up of 1024 bytes. Okay, now what that means is it's 1024 times one of these. Okay, a megabyte is 1024 kilobytes. Okay, a gigabyte is 1024 megabytes. Okay, so to go from a megabyte to a gigabyte, okay, you're looking at 1024 megabytes. Okay, because that is the unit of storage. Okay, so a petabyte is 1024 terabytes. A terabyte is 1024 gigabytes. Okay, so what you'll have to do is put the following terms in order, starting with the smallest. Okay, you're then going to have to use a bit of problem solving. So if 4 zeros is the smallest number that can be stored using 4 bits, then you have to think about what is the largest number that can be stored using 4 bits. So what do you change these 4 zeros to? Okay, you're doing the same for 6 bits, then you have to write down how a gigabyte is made in the computer system. Okay.